Okay, I just wanted to show you now what what task 2 would look like for this challenge. So for task 2, it says the group needs a machine that will rotate a solar collection dish, it's pretty much like a satellite dish, from inside their labs. The machine must be located outside of the building and around the corner. Um, so this does take a little bit of imagination. So some of the other requirements, it needs to have a minimum gear ratio of 1 to 5 or 5 to 1. Now, what that means is that you need one gear that has a lot of teeth, and then it ultimately needs to lead to a final gear that has very few teeth, or the other way around. You could start with one with few teeth and then finish with one with more teeth. That's the gear ratio. I already said must be located around a corner, needs to be angled towards the sun, and must be able to follow the sun. So we'll go full screen for me now. I want to show you what was built. So the logic behind this build. First, you see, you got the stabilizers here. I started with just a U bracket. So this is a U bracket running through here. Then I put plates on, so to make it really long. So my mentality was that anything to this side is in the building, and anything to this side is outside of the building. So as you can see, I have my crank, and that starts this first gear. And then this gear runs to this gear, which is the same size. This gear runs to this gear, which is the same size. So I have 3 really, really big gears. And you might notice that this big gear connects to the smallest possible gear you can find. So from here, we go from this small gear. I run it all the way across, trying to make it stable, although it is hard since I made it go out a really long way. And then at the end of here, I put a bevel gear. And coming from down here, I have another bevel gear. So that's really the ultimate goal, is for the bevel gear to move the other bevel gear. And then that will ultimately spin this solar panel. So the whole goal here is as this crank spins, then this moves. Now, what I really should have done is I should have taken things like torque into consideration, because the bevel gears down there are grinding a little bit. You can kind of, if you turn it the wrong way, so you kind of have to be really, really precise with it, and it's spinning quite fast. A decent reason why it's probably spinning so fast is because of how I made my gear train. Now, if you start with big gears and you finish with a little gear, it means that your torque is really low because it's hard to get it started because the starting gear is so big. So my torque is really low, but then my speed is really high. So you see, the big gear is not spinning so fast over here when I'm turning it, but ultimately, since these gears are so much bigger than the driven gear, which ultimately ends up being this one, the driven gear just moves super fast. So if I had to change one thing about what I did, I would have started with the smallest gear. So it would have been, easy to crank it. And then if I finish with a bigger gear over here, then this would be able to spin nice and slowly. And so I could be very, very precise with where I want to aim. So I went low torque, high speed, and I wish I went high torque, low speed. So whatever, it happens. Either way, this would satisfy all of those requirements. So once you're done watching this video, just take the Google Forms little mini quiz, and then you'll get credit for task 2. So thanks, guys.